Are you trying these before you check your answers? I hope the answer to that is yes. All right, let's write this equation out. The production of nitric acid, so that's going to go on the product side, and it gives you the formula there for nitric acid, and acids are going to be in solution of water, and nitrogen monoxide, so and nitrogen monoxide, which is a gas. Didn't tell us that, huh? All right, I need to add that. Is the reaction of, all right, hold on. The production is, to produce this, we need to get a reaction of nitrogen dioxide, which is also gas, and water. All right, so we'll put that on the reactant side. Nitrogen dioxide and water. All right, so let's balance this before we start. We got to balance it before we do stoichiometry. All right, can we just look at this? And yeah, don't think I can do that in my head. Let's show our work. All right, nitrogen, oxygen, hydrogen, and I want to put these oxygens together. It'll make it easier to add it. All right, nitrogen, hydrogen, and then the two oxygens, they appear in two different locations, so I'll put them each on their own line. All right, and then side by side, nitrogen. Now the nitrogen here appears on two sides. All right, well that's fine. Hydrogen and two oxygens. Okay. Shucky ducky. Would not have done that in my head. All right, so 1, 2. This one's from the nitrogen dioxide, and the last O is going to be from the water. Over to the product side. 1 from the acid, 1 from the gas, 1 from nitric acid, and 3 oxygens from the nitric acid, and 1 from the number of molecules. All right, so start with the number given, 5.00 times 10 to the 22nd molecules. Molecules of NO. Boy, it's a big word. First step, what is it? The first step in all or most stoichiometry problems is to convert to moles. And why is that? Let's take a moment and actually just keep going. All right, convert this to moles. The moles, there's a conversion factor from anything we need to know to moles. Well, that's why we convert to moles. If it's not already in moles. All right, so we need molecules of NO, and we need to convert that to moles of NO, right? And since we're counting molecules, it's just a thing that you count. We'll use Avogadro's number, 6.022 times 10 to the 23rd of anything. A mole is just that number. So let's cancel out the units. All right, so you're gonna have to imagine that I have more room here. So continuing on sideways, we have moles of NO. All right, I think I can fit that in here actually. So 1 mole of NO is equal to 3 moles of NO2. All right, and so these will cancel out. All right, so just imagine, just keep going on here. So the last step is to convert to the desired unit. Unless it's asking about moles per moles of NO2, we still have one more step to do. Familiar territory here. All right, let's get rid of moles. So put moles in the denominator of NO2. All All right, and we want grams of NO2. All right, moles to mass, mass to moles. Let's cancel these out. Moles to mass, mass to moles. All right, that's right. We need our periodic table. All right, so I'm just copied and pasted portions of it from our textbook. NO2. Okay, we got N. All right, we're given a value with 3 sig figs, so I'm just going to go to 4 digits here. All right, N is right there. Nitrogen, 14.01, and then oxygen, it's right there, 16.00, and there's 2 of them in NO2, so that's going to be 32.00. All right, so when you add them up, you're going to get 46.01 grams per mole is the molar mass of NO2. All right, so let's put 46. I want to switch up the color here. Let me go back to my 46.01 grams, and we've completed our setup. Just got to punch these numbers in our calculator. 5 divided by 6.022 times 3 times 46.01. Yikes, big number. All right, so what I get is 115 if I round to 3 digits. Now, don't forget your base and exponents. Right? When we're dividing these, we're going to subtract the. We keep the base, which is 10, and we subtract the exponent, which becomes -1. Right? 22 minus 23 is -1. All right, now this is not proper scientific notation, so we're going to have to move the decimal over twice to the left. So the final answer is going to be 1.15 times 10. And then if you move it to the left, this has to increase by 2. So 0, 1, 1. We don't have to write ones. And in fact, we could just, 1.15 times 10 is going to be 11.5 grams of NO2. All right, it's probably the best. It's probably the most. What am I trying to say here? That's probably the best way to put that number. Okay,